So we're going to take a look at the important equations that are going to help us solve problems with parametric equations. Well, the first thing we need to know is how to do the ds concept. Whenever you have parametric equations, you're going to be given x equals, I don't know, something like 6 cosine t or whatever. And then on the other side, you'll be given y equals, I don't know, square root of 1 plus x or something. I don't know. Who knows? And x and y are given to you. You're going to need to find the derivative of x, the derivative of y, square them, and then do the square root. That'll give you this ds concept. ds is very important for solving pretty much any of these other ones. You're going to find a ds there. ds is over here. All right, so that's ds. This is basically like you're trying to sort of calculate the slopes of these of the curves along these lines here. ds. Another thing that we need to know is that if you were going to do dy over dx, that's actually pretty simple because it's just like L'Hopital. You don't have to do anything weird. It's just dy and dx on the top and on the bottom. That'll simplify nice and easy. And parametric equations are cool. Next thing is arc length. This is when you're going to need to know that ds. All right. So you just plug in this simple ds formula, and you'll integrate that over t, and that's going to give you the arc length. Okay, arc length. There you go. I don't know how long that arc length. What you got to do is use ds, the x and y, plug it into this formula. Next, let's say you wanted to do the area under the curve. That'd be all this. All you need to do is just take this formula. This is for if you want to integrate it through the x-axis, that'd be this one. Then you need to use 0 to t, of course. You just take the y equation and integrate it over the well, you have to also take the absolute value of the derivative of the x. Okay, so it's y dx. That'll give you the x-axis. Or if you want the y-axis, that's this direction. Okay, that would be like all this stuff. I don't know. I guess all this stuff. Right, this is over the y-axis rather than the x-axis. Then that would be x dy. All right, you're gonna need the absolute value over that dy because sometimes you get negatives. Obviously, there's no negative area. So y dx for the x-axis and x dy for the y-axis. That's simple. It's kind of going to be the same thing over here when we do the surface area rotated about an axis. This is just rotated on the curve, flat, two-dimensional. If you want to make this 3D and rotate it about an axis, I'm going to try to wrap this up because there's the lawnmower coming. But all you need to do is take your formula, which would be 2 pi right here. You're integrating from 0 to t, and yeah, you're just going to take y ds. And you're going to have to go calculate ds again. So it's y ds if you want to do it over the x-axis, and it would be x dx if you want to do it over the y-axis. All right, these are pretty simple. There's nothing too crazy about these, right? And then let's just say you want to do, probably the hardest thing that we need to do is find like the centroid of a curve, I guess. So here's, first you need to find the length. Once you've done that by using your ds, integrating that over t, then you can go plug this into x bar. That would be 1 over L, and then it's just x ds dt, and then over for the y bar, it's literally just y ds dt. So like the equations, to solve parametric equations are really simple, really easy. It's just that sometimes it gets a little funky on these, but still, you can see how the setups are actually very easy. It's literally just y dx, x dy, y ds, x ds. All right, so easy peasy lemon squeezy.